So now let's take a look at applying the science DMZ principles to a supercomputer center network. One of the things that's useful in a supercomputer center is there's typically a global file system that ties the different resources together. So you have a big HPC resource or multiple big HPC resources, maybe a data analysis resource, and some data transfer nodes, all of which mount a central file system. And the central file system turns out to be key in wide area data transfer workflows. The other thing to remember is that the science DMZ itself, may not look like a discrete entity here in the same way that a science DMZ looks like its own discrete thing if the science DMZ is a small, separate enclave at the site perimeter like it did in some of the other diagrams. In this case, by the time you end up putting all the stuff that needs to be treated properly for high performance into the science DMZ, you end up with a big chunk of your network in the science DMZ. And that's as it should be, right? We scale the science DMZ up or down depending on the needs of the resources deployed within the science DMZ. The other thing to remember is in these diagrams, the office network looks like an afterthought, sort of stuck off over here off to the side, when it's actually not, right? That's very deliberate. The office network, it has potentially a bunch of individual user workstations and things like that in it. There's no reason to size that network for the big science flows, so it's out in back of the major network front end. And it also means that we don't have to drag all of the wide area science flows through that office firewall. So if we look at the way the data flow works coming into this supercomputer center network, it comes in from the wide area, comes through the border router, and down into that big core switch. Now, instead of the data transfers going into the login nodes or the interactive nodes of the computing resource, the data transfers go into the data transfer nodes and get immediately written out to the parallel file system. And if you look, the way the high latency flow and the low latency flow are broken out there, that's part of the function of the data transfer node. The data transfer node sits between the wide area and the file system. Its job is to run the data transfer tools and also to ensure that we don't have to have distant wide area resources directly touching our file system. That interaction stops at the data transfer node. The user transfers the data into the parallel file system. It's immediately available then on the parallel file system for launching jobs on the HPC resource. So we don't have a double copy workflow as we might have in some of the other simpler diagrams. And so the computing center then functions as an integrated whole. Users transfer data in, they run their data analysis, and then they can transfer the results of their analysis back out to their home institution. And if you look, we've still ensured that we've integrated performance test and measurement into this thing so that we are able to monitor the network and we're able to isolate faults. And if you want to deploy a security policy specific to the data transfer nodes, that's straightforward to do because each of those data transfer nodes has its own connection to a dedicated switch. You can provide security there that's different from the security for the login nodes of the HPC resource, and the two don't necessarily have to share fate. So this is a much larger scale deployment of the science DMZ principles, but it all works well and it scales up as needs dictate.